Okay, today is March 13, 2018 with Shirinidi. Abdul used to be here, he'll be back, and Herish. This is a shaking table. We want to use wired accelerometer and also wireless accelerometer. This is on charge, the wireless one. We have two wired accelerometers. We're gonna attach one to here and one is already attached to here. This video is how to get data from the wired accelerometers. You have to remember, you have to know the serial number which is on here, like 142189. Then you connect, the base is already connected to here, then the wireless is screwed to it. Then this cable is also tied to the accelerometer, and this is really sensitive. You have to keep it really gentle, be really gentle with it. This is a high-rise building. The wire accelerometer is coming to this station. Here you should know what station you are connecting. It starts from 0, 1, 2, 3 and 0, 1, 2, 3. We are using station 1, and you have to check, it says active already. Now it's ready. You plug in this cable, then the USB to the computer, and on the computer, and this is the box for the wired accelerometers. We take them out here, and again the serial number is here too, and it comes with this sheet. This sheet tells you it belongs to what accelerometer, what is the capacity of it, plus minus 500 G, and the sensitivity is 9.97 millivolt per G. And we come to the computer. This is the app, NI Signal Express, and we double click on the program, then we choose empty Signal Express, and from here, do you want to explain it or you want me to explain it?
I'll do it.
Okay.
This is the basic layout of the program. So now one wired accelerometer is connected to the sample. First step is first file, and we have to go to new project.
This is a new project.
Then add step. In add step, we have to first assign the signal in which we have to connect to the sample. So we go to acquire signal, and we have to select the first option, DAQMS acquire. In this, we have to go to analog output input and the acceleration, what we are recording by this accelerometer.
Then this small blue window should pop up here. If not, then you should redo it.
And in this first physical, you have to check that to which block you have connected your accelerometer.
Like from this base, we have plugged it to number 1. Here we have to check number 1. That's why that number 1 is important.
Then click OK. This kind of window will appear,
and then you come back to this chart.
No. First, we have to go to the bottom.
Double
check whether the particular signal which you have connected to the base, is it okay. You have to check the port. So first port you have connected, so it is correct.
And you have to check only the ones which is already like
connected.
Connected.
Next step is
you come to the chart.
Yes, to the
like amplitude range is plus minus 500 G. Then we put plus minus 500 G. It is G. The unit should be G.
Yeah, it is G.
And if you look at it here, it automatically gets updated for this one. Yeah, sensitivity is 9.97 mVg sensitivity. Then you put sensitivity here, and this is the unit, should be the same unit as this one. Then rate. This
The
is
rate of recording depends upon each experiment. So specifically try it out from 10K and below. So depending upon our experiment, we have kept it at 5.
oh, you may go beyond 10. It depends on you.
Yeah.
The more you go, the more sensitive the accelerometer is, and if you go too sensitive, you might catch up lots of noises. And if you go really low, like 2K, like 2 hertz, 2K hertz, you might like lose lots of peak points.
Yes.
So you should find at what range you are taking many data, and then checking your readings.
Exactly. Now in this acquisition mode, there are two options. We have to select as continuous samples. Next, in this tab, we don't have anything. In calibration also, we don't have to touch anything. Let's go to triggering. Nothing we have to do here. Advanced timing, we have to select use relative timing. This option is only used when we are using relative timing. For this particular experiment, we are using relative timing. So I have checked this box.
And this is the period, how much you want, how long you want it to collect data here.
Exactly.
Maybe 10 seconds. And it's up to you and up to the earthquake data you have, how long it shakes the table, then you go with the adjustment for that cell.
Okay, so after all this table is finished, we have to go to data view, right click on this sheet, signals, add signal. Here we have to select acceleration because we are recording acceleration in this particular accelerometer.
And since only one station is connected, that's why we have just one here. If you connect all 4, then you have 4 stations here.
Click OK. Now go to recording options and select record. Come back to data view. Now this completes the first step. Now second step is we have to save the particular reading what we get from the first step. So again go to add step. Here come drag down the option and select the load save signals. In this go to analog signals and select the option ASC2/LVM. This will give you a control box. First click on the folder option.
Where do you want to save it?
Where do you want to save it? So
It gives you in text file.
yeah, it gives you in text file. I can
Like, let's say example, sample.
Okay. And come to the bottom. In export file type, you have to select generic ASC.
Text. So it says text. If you do not choose that text, later on you'll be having trouble opening the file. It won't open, then you cannot copy paste it to Excel.
Yes. Next is time access preference. As we are using relative time, we have to click on relative time.
And do not click reset relative time here.
Yes.
Leave it as it is.
Now second step is over. Come back to the first step. So everything is done. We can go to data view. Now we can run the experiment.
Now, Abdul, would you hit it just to get that?
Ready? Start when you're ready.
1, 2.
Yeah.
Here you have to hit record,
Yeah.
then hit. Here it shows you the data like this, then stop it. The stop was here.
Yep.
If you like reverse the video, you will see it to stop option was next to run. Run is also here. You run, then you stop, and then you go to the file which you said sample. It was in desktop, Hussein, Herish Hussein, and then sample. This is your output. Acceleration in G versus time in seconds. say Control A, Control C, you go to Excel. You already have an Excel ready here. If you open the previous Excel, please.
Okay. Shall I open that?
Yeah, because here, see, this is the previous sample. We copy pasted 2 samples actually, then we drew 2 of them, then we removed 1 of them, so you guys see how this shape is. And here you decide the 5G, 10G, 8G works for your data. For this one, 5G gives a good result, is like almost 3G. And you come here and then Control V, please.
Okay.
The data we copied, Control V. This is your data. You just draw this. You go to Insert.
Search.
And here is where the headache starts. Here, this is your data. You have to really play with your
X and Y axis.
yeah, X and Y. See, this time it was beyond 4. It means Abdul this time hit the structure harder. Next time be gentle. And actually the wireless accelerometer, this wireless one, this is the wireless one charge storage. It has capacity plus minus 10G. But this one, the wired accelerometer, has the capacity plus minus 500G. So the lower capacity, the more accuracy, the less, the more capacity, the less accuracy, and vice versa is true. Since your capacity is low, like 10G, but your accuracy is much higher. And here you might play with this, saying minimum, maybe starting from 4, and this up to 6. Then you see the data like more clear. You see it is, now you can see this is like acceleration versus time. So this is acceleration in G, this is time in seconds. And we will take the data using El Centro, shaking the building model again, and then we'll collect our data. Hope it was helpful. Thank you.